Trappist-1e. If Earth had a long-lost twin raised in a colder, dimmer neighborhood, it'd be Trappist-1e. This rocky little sibling orbits a faint red dwarf star so closely that it completes a full year in just over 6 days. But thanks to its sun's low wattage, the planet still has Earth-like light levels. It's got the right stuff, too, nearly the same size, similar gravity, and a dense iron core under its crusty skin. No thick gas blankets or icy fluff, just pure, solid planet. And here's the thing, it sits right in the habitable zone, where liquid water could chill without immediately boiling or freezing. That makes it the best candidate in the Trappist-1 family for hosting something wet, wiggly, and possibly alive. Kepler 452b. Kepler 452b is like Earth's older, bulkier cousin who still lives in the habitable zone but shops in the XL section. With a radius 1.6 times bigger than Earth's, this super-Earth probably has some serious gravity, enough to make a simple jog feel like a powerlifting session. It orbits a star that's practically our sun's doppelganger, at a distance just a hair farther out than Earth's orbit. Its year runs 385 days, close enough that your birthday wouldn't shift much if you moved there. And the big deal? It sits squarely in the zone where liquid water could exist. That means if conditions are right, there could be clouds, rain, maybe even oceans. But Kepler 452b's been at it longer than we have. It's 6 billion years old, which gives it a 1.5 billion year head start on building or losing life. Kepler 186f. If Earth had a quiet cousin living under red mood lighting, it'd be Kepler 186f. Just 10% bigger than our planet, it's likely rocky and stable enough to walk on, assuming you don't mind the colder neighborhood. Kepler 186f orbits a red dwarf star, which burns cooler and dimmer than our sun. That means it only gets about a third as much energy as we do. If life existed there, even the plants might look different. Think burgundy forests instead of green jungles. It still sits in the habitable zone, though, right on the edge. Not too hot, not too frozen. Just enough to give liquid water a fighting chance. Located 500 light-years away, it's not exactly next door, but for a planet orbiting a star that's barely glowing, it still checks a lot of Earth-like boxes. Gliese 667c. Gliese 667c is like Earth's heavyweight cousin, who moved to the neighborhood with mood swings and permanent jet lag. It's a super-Earth, bigger and bulkier than our planet, but still rocky, stable, and orbiting right inside its star's habitable zone. That star, Gliese 667c, is a red dwarf. So while the planet gets enough light to possibly host liquid water, it's likely tidally locked, meaning one side bakes in endless daylight while the other freezes in eternal night. Think beach resort on one hemisphere, frozen wasteland on the other. Its year lasts just 28 days, and those days might be intense since red dwarfs are notorious for stellar flares that could fry the atmosphere like microwaves. Still, Gliese 667c remains a top contender for habitability. With temperate zones along its twilight belt, it could still host life, not just the kind that minds a little radiation and a lopsided sunrise. Trappist-1f. Trappist-1f is like Earth's slightly chunkier sibling who decided to speed-run the calendar. It's just a tad bigger than our planet, but instead of taking a lazy 365 days to orbit its star, it whips around in 9.2 days flat. That's right, birthdays every week. It orbits an M dwarf star, which means the whole system runs cooler and dimmer, like living under a heat lamp instead of a sun. But despite the chill vibe, Trappist-1f still hangs out in the star's habitable zone, where liquid water might still be on the guest list. Now, odds are it's tidally locked, so one side might be sun-baked to a crisp, while the other's deep frozen, like a rotisserie chicken with an ice pack on its back. Kepler 62f. Kepler 62f is like Earth after hitting the gym. A supersized version, about 40% bigger, orbiting a cooler, quieter star in the constellation Lyra. It takes 267 days to complete a year, so your birthday comes a little early, but not alarmingly so. It sits neatly in its star's habitable zone where water could, in theory, stick around without freezing solid or boiling off into the void. That alone earns it a seat at the "maybe life exists here" table. Its exact makeup is still a mystery, but odds are it's rocky like Earth with more surface area to trip over. The big question is whether it's more tropical paradise or deep freezer. Still, for a planet 1,200 light-years away, Kepler 62f checks the right boxes: big, stable, and potentially wet. If it's been thriving all this time while we've been binge-watching sitcoms and burning toast, hit that subscribe button because we clearly need to up our game. Kepler 1649c. Kepler 1649c is the closest thing we've found to Earth's twin if Earth lived under mood lighting and rushed through the calendar. It's nearly the same size, just 6% bigger, and it orbits smack in its red dwarf star's habitable zone. A full year here lasts only 19.5 days, so you'd be aging like milk, but in style. It gets about 75% of the sunlight Earth does, meaning temperatures might be just right for liquid water, assuming it has an atmosphere that isn't being fried off by stellar flares. It's likely rocky, which is good news for walking and bad news for floating. But that red dwarf it's clinging to is moody, prone to flare-ups that could strip the air off faster than a cheap tarp in a hurricane. Still, at just 300 light-years away, Kepler 1649c remains a standout candidate for life, or at least a very scenic, high-risk vacation spot. Proxima Centauri B. Proxima Centauri B is our closest cosmic neighbor with Earth-like potential, just 4.2 light-years away. It's a super-Earth, slightly heftier than our own, and orbits smack in the habitable zone of Proxima Centauri, a red dwarf star with a bit of a temper. Its orbit lasts just 11.2 days, which means you'd rack up birthdays faster than loyalty points at a coffee shop. It's probably tidally locked, too. One face always sunbathing, the other frozen stiff. Great if you like permanent sunrises or sunsets. Take your pick. But here's the catch. Proxima Centauri is a flare machine. One bad burst in the planet's atmosphere could get peeled off like paint in a sandstorm. If life exists there, it'd need sunscreen measured in lead. Kepler 442b. Kepler 442b is like Earth after a bulk upgrade. It's bigger, beefier, and orbiting a cooler, quieter K-type star. With a radius 1.34 times Earth's and a year that lasts just 112 days, it's technically a super-Earth, though you'd feel it in your knees with 30% more gravity pressing down. It sits comfortably in the habitable zone, soaking up just enough starlight to keep the potential for liquid water alive, despite an estimated average temperature of minus 40 degrees Celsius. Yep, that's the kind of place where your coffee freezes mid-sip. Still, it's likely rocky and gets enough energy to make photosynthesis possible, which bumps it high on the list for life-friendly worlds. If you're dreaming of alien plants, this might be their quiet, frozen home turf. Teegarden B. Teegarden B is Earth's look-alike in a funhouse mirror, close enough to be familiar, but living under very different lighting. It orbits a dim red dwarf called Teegarden star, just 12 light-years away, making it practically next door in cosmic terms. With a mass just slightly heavier than Earth's, it's a super-Earth that hangs out comfortably in its star's habitable zone. The potential for liquid is definitely on the table. But the planet is likely tidally locked, with one side always facing the star like it's stuck in a staring contest. At one point, it topped the Earth Similarity Index charts, making it look like a front-runner for alien Airbnb listings. More recent data trimmed that optimism, but it's still one of the best bets we've got for Earth-like conditions. LHS 1140b. LHS 1140b is like Earth's buff cousin who moved to a cooler part of the galaxy, and maybe, just maybe, brought an ocean or two. This super-Earth orbits a calm M-dwarf star in the habitable zone, making it a prime target for anyone hunting life beyond our backyard. It's way more massive, up to 6 times Earth's weight, so walking there might feel like wearing a weighted vest, forever. But its lower density hints at something juicy beneath the surface, maybe a thick atmosphere, or a water-rich layer keeping things interesting. Tidal locking is most likely, but with possible signs of water vapor, carbon dioxide, and nitrogen floating around, this planet's air might not be so alien after all. TOI 700e. TOI 700e is like Earth's slightly smaller sibling who moved 100 light-years away and found a spot under a much dimmer sun. At 95% Earth size, it's practically a twin, just with a tighter orbit and redder skies. It circles a cool M-dwarf star every 28 days, landing squarely in the habitable zone. That means liquid water could exist on its rocky surface, assuming it has the right atmosphere and isn't getting zapped by stellar tantrums. Discovered by NASA's TESS mission, TOI 700E has been turning heads for being one of the most Earth-sized planets in a Goldilocks orbit. It's not too hot, not too cold, but still full of unknowns. Will it have a thick protective atmosphere, magnetic fields, alien pond scum? No one knows yet, but for a planet this close in size, orbiting a star that's not too wild, TOI 700E holds a front row seat in the habitability race. Ross 128b. Ross 128b is the strong silent type of the exoplanet world, just 11 light-years away and orbiting a red dwarf star that doesn't throw temper tantrums every few hours. That alone makes it stand out in a galaxy full of angry flare-throwers. It's a super-Earth, about 1.4 times our mass, and likely rocky. Despite orbiting much closer to its star than Earth does to the Sun, it stays temperate, like standing next to a campfire instead of inside one. Odds are it's tidally locked, meaning one side bakes in eternal daylight while the other never sees the sun. Still, with a decent atmosphere or some cloud cover, the temperature could balance out just enough for water to exist, possibly even in the twilight zone between the two extremes. We don't know much about its air or surface yet, but Ross 128b is one of the most promising neighbors we've got. Kepler 22b. Kepler 22b is like Earth's bigger, mysterious cousin, who lives in a sunny neighborhood but won't return your calls. At 2.4 times Earth's radius, it's big enough to be a super-Earth, or a mini Neptune in disguise. Nobody's quite sure. It orbits a star similar to our Sun and sits right in the habitable zone, soaking up just enough energy to keep things cozy. If it has an Earth-like atmosphere, surface temps could hover around 22 degrees Celsius, basically perfect for beach days, assuming it has land, or beaches. But here's the mystery. We don't know what it's made of. It could be rocky, ocean-covered, or a gassy world with no surface at all. Kepler 69c. Kepler 69c might look like an Earth candidate on paper, but zoom in and you've got a strong Venus vibe with a sunburn to match. It's 1.7 times Earth's size and orbits a G-type star similar to our Sun, right in the so-called habitable zone. Sounds promising until you look at the fine print. Its 242-day orbit places it in a suspiciously Venus-like position, and its star isn't quite as bright as ours. That means Kepler 69c could be slow cooking under thick clouds, caught in a runaway greenhouse effect. If that's the case, expect searing heat, crushing pressure, and an atmosphere that's less breathable air, more toxic stew. Think less Earth 2.0 and more lava sauna with an attitude. Still, it's a valuable clue in the exoplanet puzzle, reminding us that the habitable zone doesn't always mean habitable. TOI 700D. TOI 700D is a solid contender in the Earth but not quite club. About 20% larger than Earth and likely rocky, this super-Earth orbits a cool M dwarf star every 37 days, fast-paced but not frantic. It lives in its star's habitable zone, that cosmic sweet spot where liquid water could hang around without freezing or boiling off, but don't pack your bags just yet. The planet is probably tidally locked, meaning one half lives in permanent daylight, while the other freezes in endless night. Scientists are still guessing what the atmosphere is like, though. It might be dense and protective like ancient Mars, or it could be thin and unforgiving. Either way, TOI 700D checks enough boxes to stay on the radar for possible life. Trappist 1G. Trappist 1G is like Earth's bigger, bulkier roommate, living way too close to a dim red star. It's 13% wider and about 32% heavier than Earth, making it a solid super-Earth and possibly the heavyweight of the TRAPPIST-1 crew. It takes just 12.4 days to orbit its star, meaning your year would be over before your coffee supply. Still, it hangs out in the habitable zone, where temperatures could support liquid water if it has the right kind of atmosphere. Speaking of which, that's the wild card. With its mass, it might hold on to a dense blanket of gases. Or if the atmosphere's gone, it could be wrapped in an icy shell colder than your ex's last text. TRAPPIST-1G is probably rocky, like Earth, but the details are still sketchy. It's not a perfect twin, but in the search for habitable worlds, it's definitely one worth watching. TOI 715b. TOI 715b is like Earth's thicker cousin, who sprinted ahead on the orbit track. At 1.5 times our width, it's officially a super-Earth, big enough to feel the gravity difference in your joints, but still potentially rocky beneath the boots. It hugs a red dwarf star in just 19 days, but don't let that speedy orbit fool you. It's parked right in the habitable zone, where liquid water might still hang around without instantly vanishing or freezing. The host star is cooler and smaller than our Sun, meaning TOI 715b sits much closer without getting scorched. If its mass lines up with its size, it could be rocky, with the potential for oceans, clouds, and something living just under the radar. They orbit like us, shine like us, and maybe even host life like us, but they'll always be Earth's wannabes, waiting for the day we mess up.